What's up, guys? Welcome back to the eCoreAcademy e-learning platform today. My name is AJay Raj, back with the geometry video for you all. Today's topic is all about measuring angles, and before we jump right into it, please make sure to subscribe down below to our YouTube channel at eCoreAcademy, hit the like button on this video, as well as hitting that post notification bell to get notified on any of our channel's latest posts. Alright, like I said, today's topic is all about measuring angles. The previous video that I made was all about measuring length. So this is going to be a bit more similar to what length was in terms of what this whole presentation contains, but there are many more aspects of angles than there are just lengths. So if you haven't already known, angles are a very important geometric concept. A lot of relationships and a lot of geometric portfolios revolve around angles and angle relationships, how they're measured, and real life applications for angles is very important to discover. So today's theme of our lesson is all about discovering what are the properties of angles and how exactly are angles measured. And I will explain exactly what an angle is if you aren't necessarily familiar, or if you need a refresher on exactly what that is. And I will explain all of these different relationships and properties that angles have and how to actually physically measure an angle. It's very important that we do so. Just as you use certain tools, say for example like a ruler or a fair ruler to measure length, you have certain tools to measure angles in real life with the same exact kinds of applications. So let's jump right into it. So our first slide is all about angle identification. So it's all about how to name an angle. So I'm going to show you what an angle is first and how you are going to actually name an angle when given a certain extension. And if you haven't already, please view my first video that I made, first video chronologically that goes along with this geometry course, and it has to do with basic geometric terms and concepts. Please refer back to that video because I go through many of these basic definitions that you will need to know all throughout geometry. There might be some things that you might not understand that I'm saying now, but I go through it completely, and I will link that in the description to the basic geometric terms and concepts. It's very important that you see that because I do go over angles and certain very vague angle relationships. But if you don't know what an angle is, just starting off before we actually identify what an angle is the figure that is formed by two rays called sides that share the same endpoint. So an angle is technically a figure, and that figure can be described through a certain relationship and through a certain calculation, and it can be calculated through degrees, which I will also get into later. It's a customary unit of measure for angles. So I'm going to draw a little diagram here, and like I said here, it's a figure that is formed by two rays, and it's the opening section of that of those two rays, that intersection of those two rays. So say for example, this is one ray right here, and this is another ray. And you can draw the ray in an infinite amount of patterns as long as they share a same point, which is your vertex right here. And the vertex plays a very, very key role in naming an angle. But just to give you a little recap on what an angle is, it's basically this little figure, this arc that's formed on the interior of these two rays. So this little arc right here. And that's called an angle. And that angle has certain measurements and certain relationships with other angles that can be formed in figures, such as squares, triangles, etc. And they can also have different relationships with the side lengths that they're contained by. And in this example, it has to conclude with rays. And rays are often used for relationships, but angles can be formed through line segments, rays, and lines in general. All right, let's see how we can actually identify and name an angle. So, ways to name an angle. One way that you can name an angle, our first step here, is the letter of the vertex of the angle. So say, for example, I'm going to refer back to this ray here. And if we look at this vertex, which is a common endpoint shared between two rays, and that common vertex has the letter A identifying what that vertex is, then that means that this angle here, this arc here, is also equal to angle A. So that could be angle A. And another way to write an angle, as I will show you here, is angle. You can write it in word form, which is angle A, representative of the vertex. And it can also be angle A, like this little opening mouth here. That's another way to write an angle. That's also equivalent to the word form of angle. And the second way that we can name an angle is if you look at this ray. I'm going to draw another ray. So it's a bit more organized here. So if you look at this right here, and another way that you can identify how to identify giving a symbol for the angle is by looking at the 3 points in array acute, and you can see that there's 3 points, one being on a ray. There can be 3 entire points. One includes the actual vertex that you're given, and that's the vertex of the angle. So I'm going to draw a little angle here, and it's corresponding to this vertex here. And a way that you can do that is, say for example, there's 1 point on this ray here, 1 point with the vertex, and another point on the opposing ray. If you look at that relationship here, you can actually identify the angle by utilizing these 3 points to identify the specifics of the angle. And what you're going to do is, you're going to say, for example, you put A for this point here, B for this point, and C for this point over here. Now, the name of this angle would be angle ABC. And the way that you figure that out is, you can start in a clockwise rotation from the top and doing so to figure out the angle. But all you really need to do is really need to know is that C and A, being the outermost parts of this angle, they're always interchangeable. They can always be changed around, but B must always be the angle. B must always be the center of this, because B identifies the angle, and it's very similar to just saying angle A. I would recommend that you guys just write down angle A instead of angle ABC, because it's the same thing, since the angle is always a middle value. And finally, what you can do is you can put a symbol on the angle. And what that looks like is, you can draw a ray with no labeling. So your vertex or your rays would not have any label points. And say, for example, this is the central angle. What you can do is you can put like a little tick mark on it, a letter. It can be like a letter A, and you can just use that to deliberately put that on the angle, and that would also be the name of your angle. So it's very simple to name an angle, very simple concept, but I just want to get that out there so you all know. And next, we're going to look at the process, because remember how I said we're going to figure out how to actually measure an angle in real life and its real life applications. So I'm going to show you guys the process. So how to measure an angle. So before we get, how you're going to actually measure an angle, you're actually going to have to use some tools if you're going to do so. And these tools, and this specific tool, that all you need is your angle and, of course, your protractor here that I'm showing here. And that's the only tool that you need. And it's a circle with a curved edge and straight bottom that is used to measure angles. It's very simple, and I will show you that process. And a degree is also very important to know, because degree is the customary unit of measure for an angle. So it's what we put in terms of. So say, for example, we're trying to put into terms and measure a certain length and relationship between angle. We have to have some sort of calculation format. So say, for example, you're calculating, length and width. You might be using, centimeters, inches, meters, all of these customary metric system units. But for degrees, for angle measures, you would be using degrees for now, for customary units. But there are other different units that you can use, but this is the very customary unit for it. And this is what a protractor looks like. So basically what it does is it shows levels from 0 to 180 degrees, and 180 degrees being the maxed out angle, which is a straight angle, which is the most that a singular angle can be. And as you can see here, you can see overlapping lines of going from 0 to 180 in increments of 10. And basically, if you were given an angle like this, I'm going to just draw 2 rays with a common vertex. You would be picking up this protractor, and you'd put the vertex at right here. You'd place the vertex right here, over here at this little open circle, and after you place the vertex, you'd see where the top, and you'd line after you put down the vertex here, you'd line up this bottom line all the way on the edge of this protractor, and you'd see where this ray would intersect, and you'd see what number it would intersect, and whichever number it intersects, well, that would be the angle measure. And just to throw this out there, it's all about location. If there is sometimes relativity with placement of an angle if you're trying to see where objects are in relation to an angle. So basically, the interior or inside of an angle is basically what's contained between these 2 rays. So at this point here, if I label it point B, that is on the interior of this angle. And exterior is basically everywhere outside. So right here, or here, these are exterior points from the angle. Next, we're going to look at postulates and properties. So now we've first completed our first section on how to actually measure an angle, and how to identify an angle. Now we're going to look at more of like the relationships and concepts and the properties that angles must follow. So we're going to look at our first postulate, which is angle addition postulate. And if you guys don't know, a postulate is basically a geometric law that must be followed for all given concepts. So the angle addition postulate states that if point D lies in the interior of angle ABC, then the measure of angle ABD plus DBC equals ABC. So I'm going to write that out for you so you guys don't get confused, but it's actually a very, very simple concept. So if you're looking here, if I'm going to draw another ray group to discover what an angle is, if you draw this right here, and you look here at the central angle, right here, after looking at this angle, you can tell that if point D lies on the interior of angle ABC, so we know that this angle is ABC, that's a B. If you guys don't see that, if it's hidden by the text, sorry about that. So it's angle ABC, meaning it's also known as angle B. And say, for example, there's a point D. It lies on the interior, meaning between the two rays. Like I said before, interior is opposite to exterior. And if point D lies on the interior of ABC, then the measure of angle ABD, which is AB, point A here, and then point B here, and D. So basically what you're doing is you're connecting segment AB with point D, and I'm going to name this point D. And it has its own angle measure here. And you also form another angle, which is DBC, as shown here. I'm going to make that another arc. Well, after looking at these two relationships, this angle right here and this angle right here, it's basically saying that since it's intersecting this angle, the sum of these two smaller angles must be equivalent to the bigger angle, which is basically the sum of angle ABD and DBC equaling the angle ABC, the total angle. So basically, if you have an intersecting of an angle, those two intersected parts will always be equivalent to the whole that was originally given. And I just want to throw this out there. This is a very specific form of intersection. Intersection is when you split an angle, but bisected or bisection of an angle is when an angle is split or intersected into two smaller equivalent angles. So whatever angle you're given, and if you bisect it, say for example, you're given a 100-degree angle, and you bisect it, you'd be given two 50-degree smaller portions of the angle. And also, what I wanted to throw in there is bisection does not necessarily have to be given on a given ray or a given angle. It can also be represented for a straight angle, and I will show you that later to come. Oh yes, and also if you're given a angle here, it can be split by not just a line, because remember, when you're bisecting something, it has to be a line. So it can be split by a line segment. It can be split by a line segment, this angle here, a line, a segment, and even a ray. So I'm just going to put that here. A line, a segment, and a ray. Okay. On to our part 2 of postulates and properties. We have our second postulate, which is the angle congruence postulate. And the angle congruence postulate is very similar. It's very simple, sorry. It states that if two angles have the same measure as measured by a protractor, which is our tool of measuring, then the angles are congruent. And the corollary is also true, which basically states that if two angles are congruent, they must have the same measure as measured by a protractor. So all this is saying is, if you're given two separate angles and each one is measured by a protractor and they each give a value of 70 degrees, that's basically saying that if they both have the same exact angle measure, since 70 degrees is equivalent to 70 degrees by the reflexive property of congruence, we can see that both of those angles must be congruent. And the corollary is true if you're saying that angle ABC is congruent to angle DEF. That means that they both must have the same exact angle measure. It's very simple. And the sign or symbol for congruence is basically an equal sign with a little wave at the top. That's what a congruence sign looks like. And just throw this out there, this does not always have to do with a fair measurement, meaning it does not always have to be deliberately measured by a tool in reality. It can also be proved in algebraic terms. So meaning you can use variables to express, say, for example, if a value is 2 times greater than this value, you can say it's 2x, 2 times this variable, and you can give representations for real life objects. And now we're going to move on to the types of angles, and this is more of like angle classification and relationships. So we're going to look at our types of angles, and they're all classified specifically by the degree amount, so the amount in degrees that they are given. So we have our first angle, which is an acute angle, and it's merely an angle that is less than 90 degrees. So it's an angle that is less than 90 degrees. So it's between 0 and 90 because we cannot have negative angles. And then we have our obtuse angle, which is greater than 90 degrees, but less than or equal to 180 degrees. So what that's basically saying is an obtuse angle can be greater than 90 degrees. So any value like 90.0001 would be an obtuse angle, but it can be less than or equal to 180 degrees. So it can still be an obtuse angle, even if it's equal to 180 degrees. So it must be within 90 and right above 180. And then finally have a right angle, which is equivalent to 90 degrees. And a right angle in a given angle diagram, as shown, is actually expressed by a square. So like I showed you here, the arc basically shows a regular angle, any other angle being an obtuse, acute, and a straight angle, which is the next one. But a right angle is shown by this little square shape here, connecting both rays. And finally, we have our straight angle, which measures exactly 180 degrees. And the cool thing about this is a straight angle is just a straight line. So if you're given any line and no two rays, the measure of this whole entire angle that the line produces would be equivalent to 180 degrees. And a full swing around the entire, both sides of the line would be equivalent to 360 degrees, which is also the same degree as a circle. So 360 degrees. And now we're moving on to our angle relativity, which is our last section. And these are just little relationship status, similarity, and postulate properties that angles have. So we're looking at angle relationships here. And first angle relationship is adjacent angles. So if if you're given two angles that have a common side and vertex, but no common interior points, that means these two angles are adjacent. So say, for example, you have this ray here. I'm going to draw this as an example. And basically, this ray is intersected by one line, like I showed you before, when an angle is intersected. So these two angles would be adjacent angles because they share a common interior point, being on this line, and they also share this common side. So what I'm talking about is these two angles formed. And since they both share a common side, a common vertex, and no common interior points on each of their angles, they are both adjacent. Another angle relationship we have here is our complementary angles. And two complementary angles are two angles whose measurements add up to 90 degrees. So if you're given an angle with, say, for example, 55 degrees and 35 degrees, that would equal 90 degrees. So that means that these two angles are complementary. It's a very simple concept. And now we're going to have another final relationship that's very similar to that, and that's basically supplementary angles, which is two angles whose measurements add up to 180 degrees. So rather than two angles that are adding to 90 degrees, it's just going to be double that, 180. And finally, for our last slide, we have our part 2 of angle relativity, and it's just more angle relationships. And this angle relationship is very unique. It's called the linear pair. And a linear pair is when two angles that have a common side and the same vertex, just like adjacent angles, but they have other sides that point in opposite directions. So unlike an adjacent angle, this is much more specific. So say, for example, we were given a straight line here and another line intersecting. Now, basically, all that's saying is, let's assume that this angle here And just to recap here, linear pair, they're very similar because they have to share the same vertex and a common side. But all it's stating is that these side lengths, or the sides given, must be reaching in opposite directions. Must be going in opposite directions. So this would be a common example of what is not a linear pair. So if we're looking at this angle right here, I'm going to star that, and this angle right here, you can see a major difference in them both because their given sides are not pointing in opposite directions, meaning that their top side and top side are not pointing in opposite directions here. But if you're given another example like this, where two lines are intersecting at straight sides like this, you can tell that these two angles are a linear pair since both of their sides are pointing in directly opposite directions. And just to recap, this is called a specified linear pair. Still, this is technically called a linear pair since they both share one common side and vertex right here, and since they both have two opposing sides that point in opposite directions, this is still technically a linear pair. Sorry to get you confused there, but this is a specified linear pair when both sides or both rays of an angle are pointing in opposite directions, and that can only be done when you have perpendicular lines. And finally, we have our linear pair postulate, which is another postulate, but this correlates with the linear pair. And it's saying that if two angles form a linear pair, just like this, then they are supplementary, which means they must add to 180 degrees. So if you have a linear pair, that means those two angles that are in that linear pair must also equal 180 degrees. 180 degrees, which is also a supplementary angle pair. Alright guys, so that'll be it for today's video. Hope you guys enjoyed. This has been eCoreAcademy. Please make sure to like and subscribe down below. Hit that bell to get notified on any of our channel's latest posts. Visit our website at eCoreAcademy.org to get full unlocked access to all of our YouTube videos, all of our integrated quizzes, note sheets, and worksheets that go along with each and every single video organized into core studies. You can email us at eCoreAcademy@gmail.com. If you have any questions or if you just want to reach out to us. And please visit all of our socials, which include Facebook, Twitter, and Instagram, so you can share these videos to help others out who might need that help. And, just check out all of our cool posts. So, once again, guys, I hope you guys enjoyed this. I really enjoyed making this video for you all. And yeah, that'll be it for today's video. Take care, guys. It's been AJ, and I'll see you guys in the next one. Peace.